and welcome to Grace Tutorial. In this video lecture, we will be discussing about the various methods of the preparation of the salts. First up, let me tell you the methods of preparation of the soluble salts. Well, we have the first method, that is the direct combination. So, by this direct combination method, that how a salt is formed? Well, the salt is formed by the combination of the metal as well as the non-metal. That means the direct combination of the metal and the non-metal react together to give the salt. We have the examples. When the sodium metal reacts with the chlorine, which is a non-metal, then the salt which is formed is known as the sodium chloride. Here nothing has been done, only the combination has been taken place. That means the combination of the metal along with the non-metal. Similarly, we have one more example, that is we have iron atom, Fe, or the ferrous. When the iron atom reacts with the chlorine, which is a non-metal, it gives the FeCl3, that is ferric chloride, and this is a salt. In this way, the salt is obtained by the combination of the metal as well as the non-metal. So what is the first method of the preparation of the soluble salt? Very simple to understand. Only the combination takes place between the metal and the non-metal to form the salt. Well, we have the method number 2, that is simple displacement. By using this method, simple displacement, how the salt is formed? What happens here when the acid reacts with the active metal, or when the reaction takes place between the active metal as well as the acid, then the salt is formed. But here one more thing also will be liberated, that is what the hydrogen gas. So the hydrogen gas is evolved here when the active metal reacts with the acid. For example, we have zinc. The zinc is basically a metal, and when the metal reacts with sulfuric acid, then zinc sulfate is obtained. The zinc sulfate is basically a salt by the evolution of the hydrogen gas. But how the zinc sulfate is obtained? Let me give you a clarification. Well, if you will dissociate this zinc, you will get Zn2 plus. Similarly, if you will dissociate this H2SO4, then you will get H plus and SO4 2 minus. And you know that since the zinc is positively charged particle and it reacts with the negatively charged particle of the compound, that means the Zn2 plus react with SO4 2 minus. So what happens? The Zn2 plus react with SO4 2 minus to form ZnSO4. That is the zinc sulfate. In this way, the zinc sulfate is obtained. And here the zinc sulfate has been obtained by the displacement reaction. Basically, this is a displacement reaction. But here the displacement has been done by the zinc atom. Since the zinc is an active metal and it displaced the hydrogen atom from the sulfuric acid, and it finally forms the zinc sulfate along with the evolution of the hydrogen gas. Well, we have one more example, that is when the iron, we have iron atom. Iron atom is also a metal. When this metal reacts with acid like HCl, hydrochloric acid, what happens generally? We have the metal, that is Fe. Yes, well, if you will write the metal, that is Fe2 plus, and if you will dissociate this hydrochloric acid, you will get H plus Cl minus. So what happens here basically? The Fe2 plus, since it is positively charged particle, it reacts with the negatively charged one of this compound. That means the Fe2 plus reacts with the Cl minus to give FeCl2. And in this way, the FeCl2 is a salt which is obtained by the reaction between the active metal as well as the acid. So when the active metal as well as the acid react together, the displacement takes place, and by the displacement the salt is obtained, and that is also by the evolution of the hydrogen gas. Well, the hydrogen gas is evolved here, and the ferrous chloride or the iron chloride is obtained here, and iron chloride is basically a salt. And how the salt is formed? This salt is formed by the displacement reaction. So the displacement of the hydrogen has been displaced here by the iron atom. Since the iron atom is a reactive metal, therefore it could easily displace the hydrogen atom from the hydrochloric acid, and it finally forms FeCl2, that is a salt. Well, we have the third method, that is the decomposition. Well, decomposition means there are various methods, various forms of decomposition. Decomposition of carbonates by acids. First of all, we have the carbonates will be decomposed. But by what way the carbonates can be decomposed? The carbonates will be decomposed by the acids. We have the acids like hydrochloric acid. Similarly, we have the acids like sulfuric acid. The hydrochloric acid and the sulfuric acid, and by these acids, the carbonates of these substances will be decomposed. And finally, it gives the salt. Salt with water along with the liberation of the carbon dioxide gas. That means the carbon dioxide gas is evolved here with the water molecule, and the salt is formed, which is the main product for us. Let us try to understand that what happened to these reactions. We have the magnesium carbonate. Let me give you the clarification of this reaction, that how the magnesium carbonate react to sulfuric acid to form the magnesium sulfate with water along with the evolution of the carbon dioxide gas. Let me give you the idea of that one. The magnesium carbonate, here it has the carbonate, but here the carbonate will be decomposed. That means that will be, it will be broken. So the magnesium carbonate will be decomposed by the acid, and it gives the magnesium sulfate. Well, if you will dissociate this magnesium carbonate, you will get Mg2 plus and CO3 2 minus. Right? If you will dissociate this magnesium carbonate, what do you get? You will get Mg2 plus and CO3 2 minus. Similarly, if you will dissociate this sulfuric acid, you will get H plus and SO4 2 minus. That means the positively charged part of this compound reacts with the negatively charged part of this compound. That means the Mg2 plus react with SO4 2 minus to give the MgSO4, which is S salt. But here what happened? The carbonate has been decomposed by this acid, and finally it results the gas, which is the carbon dioxide. Similarly, the decomposition of the sulfides also takes place by the acids. How? Well, we have the potassium sulfide, and when this potassium sulfide reacts with the sulfuric acid, in the exact way the decomposition takes place. But what will be decomposed here by the acid? We need to understand. Here, the sulfide will be decomposed here by the sulfuric acid. So if you will dissociate the sulfuric acid, you will get H plus and SO4 2 minus. Similarly, if you will dissociate this K2S, that is potassium sulfide, you will get K plus and S2 minus. So generally what happens? The negatively charged particle of this compound will react with the positively charged part of this compound. And finally it gives the H2S. H2S will be resulted here, and the potassium sulfate salt is obtained. So the potassium sulfate salt, this salt has been obtained by the decomposition of what? The decomposition of the sulfides. That means the sulfides has been decomposed here. That is also by the acid. That means the acid could easily decompose the sulfide here, and finally it forms the salt. Similarly, we have one more example. That is the zinc sulfide. If you will dissociate the zinc sulfide, then what happens? You will get the Zn2 plus and S2 minus. Well, if you will dissociate the sulfuric acid, you get H plus and SO4 2 minus. So what happened basically? The positively charged particle of this compound will react with the negatively charged particle of this compound, and in this way it forms the zinc sulfate. So the zinc sulfate is a compound, and this compound has been formed by the decomposition of the sulfides by the acids. So the acid could decompose the sulfide which is present here in this compound, and finally it formed the zinc sulfate, which is a salt, that is also with the liberation of the hydrogen sulfide molecule. This is what the three different methods of the preparation of the soluble salts. Now we will discuss the fourth method of the preparation of the salt. Well, if you look at this one, the fourth method we have, that is the neutralization. So the neutralizing an acid with a soluble base. Whenever an acid neutralizes with a soluble base, then what happens? The salt is obtained here. Let us take some of the few examples so that you can get it very clearly. We have nitric acid. So what is the formula for nitric acid? HNO3. And if you will dissociate this nitric acid, you will get H plus and NO3 minus. Similarly, if you will dissociate this NaOH, sodium hydroxide, you will get Na plus and OH minus. That means the positively charged particle of this compound will react with the negatively charged particle of this one, and in this way the H plus and OH minus, they react together to form the water. And finally the NaNO3, that is the sodium nitrate, is obtained. So Na plus and NO3, they react together to form the sodium nitrate, that is NaNO3. Similarly, when this acid reacts with the NaOH, that is the base NaOH, the acid, the Na plus, if you will dissociate, you will get Na plus and OH minus. So the positively charged particle of this compound will react with the negatively charged particle of this compound, and finally the NaCl is obtained in this way with the water molecule. Well, this process is what basically called the neutralization. That means the neutralization is the process of the involvement of the acid with the base to form the salt with the liberation of the water molecule. Similarly, we have acid like hydrochloric acid. When it reacts with the base such as ammonium hydroxide, the positively charged particle of this compound, that is NH4 plus, will react with the negatively charged particle of this acid, and finally it gives the NH4Cl, ammonium chloride, with the water molecule. So this is the fourth method, that is the neutralization. The neutralizing also can be done in some different way, that is the neutralizing of the acid with the insoluble base. Here, the neutralization of the acid takes place, but that is with the soluble base. But here, the neutralization of the acid takes place with insoluble base. So these are the insoluble bases, such as magnesium oxide, lead oxide. These are the insoluble bases. Well, if you will, neutralize this acid with the insoluble base, what generally happens? The positively charged particle of this compound, that is H plus, will react with the negatively charged particle of this compound, that is the O2 minus, and in this way, the water molecule is obtained here, and here the Mg, that is the magnesium, since it is positively charged particle, it reacts with the negatively charged particle of this, the hydrochloric acid to form the magnesium chloride. So the magnesium chloride is basically a salt here which is formed by the reaction of this hydrochloric acid along with the magnesium oxide. And the magnesium oxide is basically an insoluble base. Since it is an insoluble base, the acid neutralizes, the neutralization takes place between this acid as well as the insoluble base. Similarly, we have a nitric acid. When the nitric acid reacts with the lead oxide, the nitric acid, it reacts with lead oxide to form the lead nitrate. How the lead nitrate is obtained? The lead nitrate is obtained since the lead oxide is an insoluble base. Well, this insoluble base will be neutralized by the acid, and finally it gives the lead nitrate. How generally, if you will dissociate this nitric acid, you will get H plus and NO3 minus. Similarly, if you will dissociate this lead oxide, you will get Pb2 plus and O2 minus. That means here the negatively charged particle of this compound will react with the positively charged particle of this compound, and in this way the Pb and O3 whole 2, that is the lead nitrate, is obtained with the liberation of the water molecule. So that is what the fifth method. And now we have the last method of the preparation of the soluble salt, that is by the action of alkalis on certain metals or the metal oxides. We have the alkali, the treatment of alkali, that means the reaction of alkali with the metals or the reaction of alkali with the metal oxides. What happens when an alkali reacts with the metal? You know what happens? It forms the Na2ZnO2, and this is also basically a salt. It is formed with the liberation of the hydrogen. Similarly, if you will react to this potassium hydroxide, that is an alkali, it reacts with ZnO, zinc oxide, and it finally gives the K2ZnO2, which is a salt by the liberation of the water molecule. That means if you will observe the difference here the base reacts with the metal, and that's why the hydrogen is evoked here. But here the base reacts with a metal oxide, and instead of formation of the hydrogen, here it forms the water molecule. And these are the different various methods of the preparation of the soluble salts. And now we will discuss the methods of the preparation of the salt, but the insoluble salt. So if we look at the methods of preparation of insoluble salts, we have the first method, that is by direct combination. Well, the direct combination is basically simple to understand. The metal as well as the non-metal react together to form the salt. So the combination of the metal and non-metal takes place. So what are the examples? The lead reacts with the sulfur, which is a non-metal, to give the lead sulfide. Similarly, the iron reacts with the sulfur to give the iron sulfide. And these are the salts which are obtained by the combination of the metal as well as the non-metal. That is the first method. Now we have the second method, that is by the combination of acidic oxide with a basic oxide. Well, we have the acidic oxides as a sulfur dioxide, carbon dioxides. Similarly, we have the basic oxides such as calcium oxide, like this. Well, what happened here? The sulfur dioxide, which is an acidic oxide, it reacts with the calcium oxide, which is a basic oxide. So the reaction between the acidic oxide as well as the basic oxide takes place to form the calcium sulfide, that is CaSO3, the calcium sulfide. Here what happens? Only the combination takes place. The combination between this acidic oxide as well as the basic oxide. That is Ca, here SO2 is there and one more O, that is SO3. So calcium sulfide, in this way it is formed. Similarly, we have Ca and CO2 is there and O, one more oxygen, that is CaCO3, that is calcium carbonate. So the calcium sulfide, calcium carbonate are the salts, and these are the insoluble salts, and which are formed by the second method, that is the combination of acidic oxide with a basic oxide. Well, similarly we have the third method of preparation of this insoluble salt, that is by the precipitation reaction. How the precipitation? In this reaction, the various precipitates are formed. Well, let me give you some of the few examples so that you will get it very clearly. We have the barium chloride. When the barium chloride reacts with sulfuric acid, what happens here? Well, the positively charged particle of this compound will react with the negatively charged particle of this compound. If you will dissociate this barium chloride, you will get Ba2 plus and Cl minus. Similarly, if you will dissociate the sulfuric acid, you will get H plus and SO4 2 minus. That means the positively charged particle of this compound will react with the negatively charged particle of this compound. It means the Ba2 plus reacts with the SO4 2 minus to form the BaSO4. And the BaSO4 is a precipitate along with the formation of the hydrochloric acid. Similarly, we have AgNO3, silver nitrate. When the silver nitrate reacts with HCl, hydrochloric acid, the positively charged particle of this HCl, that is H plus, will react with the negatively charged particle of this AgNO3. That is, if you will dissociate Ag plus NO3 minus. So here the positively charged particle of this one will react with Cl minus. That is Ag plus and Cl minus. That is AgCl, which is a precipitate. Similarly, HNO3 is also formed by this way. And here we have sodium sulfate and barium chloride. When the sodium sulfate reacts with the barium chloride, then barium sulfate is obtained. And barium sulfate is basically a precipitate with the sodium chloride, which is basically a salt. So the salts here are obtained, but the precipitations also get formed. How the barium sulfate is formed? By the combination of these two. If you will dissociate this sodium sulfate, what you will get? You will get Na plus and SO4 2 minus. Similarly, if you will get dissociate BaCl2, that is you will get Ba2 plus and Cl minus. So what happened here? The positively charged particle of this one will react with this negatively charged particle. In this way, the sodium chloride is obtained with the formation of the precipitate, that is the barium sulfate. Well, these are the different methods, the various methods of the formation of the insoluble salts. This is what you need to understand from the preparation of the soluble salts as well as the insoluble salts. And if you would like to watch the next part of this video lecture, I would request you to press the bell icon over here to get the latest notification. Anyhow, thank you very much for watching.